All right. We have our next speaker, Lauren Mushro. Lauren is the head of product and AI research at Sapien, where she focuses on building data annotation tooling. Before joining Sapien, she worked on government agency products across the US as a senior associate at KPMG. Lauren holds a PhD in modern languages, is a published author, and continues to research language learning and the development of LLMs for translation purposes with a focus on bias mitigation in model training. Let's have a round of applause for Lauren.
You guys. Okay, here we go. It's nice to see you all. Thanks for coming. As Shai kind of just pointed out, my name is Lauren. I work as head of product and research at a company called Sapien. We are a two-sided data marketplace. We essentially work on data annotation and fine-tuning large language models. So kind of on the coattails of Chris, I'm going to also talk about ethics today. Specifically, I want to have us all investigate the question, who trained the AI model that you might use? Maybe you used it this morning, maybe you're gonna use it later today or tomorrow at work. And so let's just really dive right in here. Actually, to start off, this is a nice little image I got from ChatGPT's latest model. This is what it thinks I do every day, so. All right, so let's just jump into what the simple but fundamentals are for how AI thinks, essentially how AI models are processing information to understand the way the human mind works, right? So we're gonna talk about a process called tokenization. I'm gonna fix this so I don't do this all. Okay, so we're going to talk about a process called tokenization, which involves breaking down parts of sentences into tokens that then train AI and allow it to have human-like reasoning, right? So this actually works through something called byte pair encoding, where the model merges the most common token pairs. And here we're actually essentially teaching the model or pre-training the model how to actually predict the next item that might come in the sentence, right? So we're seeing here on the right, this is an example from NVIDIA's latest model. We see that the next token that the model might predict is jumps, right? This is a 45% chance that the fox jumps. So this is kind of the way that we're actually training the models, right? So before AI could think in this way, however, someone had to construct its worldview, right? So who trains these models? This is the question I think that we're going to kind of dig into today. And I think that it's important for us to talk about the quality of the model and how and where that quality comes from, right? So the age-old saying, garbage in, garbage out, it goes the same for AI training, right? So when we are putting in data that might have a incorrect sampling size or might be skewed, the data you're putting in is going to affect the model output as well. And very often, this data is actually trained by large swaths of people that are found at the very bottom of the machine learning stack, right? So let's jump into an example. We're just gonna take a few examples here from a group of NIH researchers who are using a ResNet 50 model to actually see how well this model was able to identify what is contained in these two images, right? So just for reference, ResNet 50 is a CNN which is trained on 50 layers of more than 1 million images. So there's certainly sufficient data for this to be able to, essentially classify what we're seeing in these images, right? So the image on the right side, the model properly classified as bubbles, okay? So it looks like bubbles. We can all tell as humans it's bubbles. On the left side, does anyone want to guess what they classified it as? The model classified it as? Yeah. A grape? Okay. Any other? Yeah. Peas? Okay. A bug. I think I got it mixed up. The left side. The left side. So that one, right? It classified it as a salt shaker. So we have kind of like a very, it really tells us like, oh, what's there really to worry about for AI models, right? Well, let's look at another example. On the right, the model classified this as a butterfly. I mean, I'm pretty sure it's a moth, but it classified it as a butterfly. On the left, any guesses? Yeah. A Dorito, that's a good one. We've got a broom. So this is, when I looked at this, it's really interesting and it's kind of funny, right? And it might actually make you think like, oh, AI is never going to take our jobs. I know we all don't actually think that, right? But then when you look at, what does this actually mean in real life? What about when a model gets something more dire and incorrect? So we're going to take the example of Barbie. Let's say a model misclassifies someone's gender or ethnicity and actually plays into some of the most tired stereotypes about that person's identity, right? So we're going to chat on a Midjourney or on a BuzzFeed article that was put out back in July, where about 195 images were generated by Midjourney. Some of you might have seen this article. They swiftly took it down. Where 195 images were classified or were generated, produced by Midjourney for Barbies from different countries, right? So let's see what the output was. And just for reference, Midjourney is trained on about 5 billion image to text pairs, and that's not all that goes into the training, right? There's quite a bit more, and they continue to iterate. But this is what we've gotten, right, from image to text data sets of 5 billion, right? So the first we get here, you can see, we have Singapore, Vietnam, and the Philippines. All of them possess incredibly Eurocentric traits. We can even go forward and look at Central Asia. Again, Eurocentric traits. Even Southern Europe possesses Nordic traits, right? So we're seeing this sort of preference for a very specific outlook on the world and a very specific segment of data, right? What about when it gets other things wrong, like worse things wrong, right? So that's when we see things that are actually really playing into stereotypes about violence, about war, about the history of the way humans interact with each other, right? So here we see, actually, just to clearly see what we're seeing here, it's South Sudan Barbie with a gun, Lebanon Barbie pictured in front of crumbling rubble, and it's really just playing into some of the most trite really understandings of human nature, right? So this leads us to the heart of it, because Barbie itself might not be important, right? Barbie is Barbie, but the stereotypes that it reinforces are. In real life, models with these types of gaps or handicaps tend to exclude or miss certain ethnicities or genders altogether, or conversely, actually, as Chris discussed, they actually tend to single out specific ethnicities in items that we see kind of with like facial recognition software utilized by police force. So this isn't just a model failure, it's a data failure, and the quality is really, the quality of the data that we're looking at is really not about objectiveness and accuracy. It's about subjectivity, nuance. How are people actually annotating that data? So let's take a look at what data annotation is and the process. So I know my audience. How many of you all are kind of aware of the process that data goes through to be annotated and then utilized to train-ish, kind of? Okay, well, we can just go over it a little. Annotation is the process of IDing key aspects of data for use in the training of LLM. So text, audio, image, video, LiDAR. Here you can actually see we have a 3D cuboid, which is the way that we're this is the data that we're kind of using to train autonomous vehicles. So the Tesla or the Zoox car, the Hyundai you see on the road, that's trained by multimodal inputs, including 3D cuboids. We also see facial recognition here in the middle, which is identification of human faces and mapping of biometrics to their facial features, utilized frequently in security software. We can get a bit further into that, the ethics of that as well. Then lastly, text ranking. This is probably the one that everyone knows quite well, which is ranking of different phrases, pieces of text for the training of text-based LLMs. So that's kind of the general idea of how annotation works. This is how we're training ChatGPT, Midjourney, and again, all of these autonomous vehicles that we have chatted on. Even DeepSeek, which classically stated that it utilized less data for training, it was built on prior models that were trained with millions and millions of data points. So let's see, let's talk a little bit about the people who are doing this annotation. So we have a few different companies that really hold the majority of the market share here. We have Mturk, Scale AI, Databricks, Upwork, Crowdflower, if I could speak, and a few others, right? Including Sapien, which is the company that I work for. So these companies employ these part-time workers. They are either paid by the hour or by annotation, and they really are attracted to this work because it's a work from home, flexible, potentially supplements some of the pay they get with their regular job, or actually makes it possible for them to get to the end of the month with their rent. However, there's a bit of a darker side to this, right? These workers have frequently been called the ghost workers who toil the digital assembly line. So these are people, wherever software developers have made breakthroughs in AI, wherever all of you have made breakthroughs in AI, that success has been predicated on a combination of the strengths of technology and also access to cheap global labor markets, typically global labor markets in the global south, right? So here we can see the kind of north-south divide that we're looking at. In some cases, these gig workers aren't always located across the globe, right? They might be centralized in what we would call a data farm, where 200, 300, 400 people are working hours and hours on end in a data center with limited access to resources like utilizing the bathroom, or even, escalation processes for something they might encounter at work, right? So just as in regular factories building a physical product, the output is always affected by the conditions for the workers. So this is something we need to consider as well, right? Factories where people are making $1 to $2 a day with no bathroom, no escalation process, and no regular benefits are not going to provide the best annotated data that we would be utilizing for for model training, right? So let's talk about a few of the issues we see in data annotation, and then we'll dig into the key of this, which is bias, right? So we see a few different items, including label leakage. So just in my day-to-day as head of product, I'm working with the operations team, looking at the results we're getting in from annotators, right? And we work with small teams. They're decentralized across the globe. We work with people from 120 different countries. And sometimes answer sets to ground truth data leak, and that means that we get monolithic answers to a data set, and that data is then unusable. So that's a classic item that we see, right? We also see inconsistent label sets or over or under constrained instructions, right? There's a way in which these companies write instructions, the operations managers write instructions that might actually be leading the annotator to a specific answer. And then, lastly, we're all humans. So as long as there is human feedback, as long as we have RLHF, there will be ambiguity in the answers that annotators are creating for these data sets, right? So there is no true right answer. We're humans, there's subjectivity, so that's something we always need to consider as well. And then finally, bias, which is kind of the reason we're here to chat today. Bias is not always, of course, the result of intentional actions. It reflects existing historical patterns and social structures that have shaped information systems. And we've even seen, that there is a default perspective that, data sets, there's a default perspective and type of data set that assumes certain experiences are more relevant than others. So let's just kind of jump into what this looks like in our day-to-day. All right, perfect. So here we can see a chart with essentially correlation correlation between GPT thought and human thought and cultural distance from the US, right? So we see, not surprisingly, that the US, Australia, and Canada have the highest correlation between human and GPT thought. We're in the US, right? So this is based on distance from the US, not surprising. On the other side, we see Pakistan, Jordan, and Egypt. So we see that the correlation actually declines the further the country is from the US, right? So we can talk about, what does this mean? Where does this bias come from? So there's a psychological term that's been coined called WEIRD. Some of you might have heard of it. It means Western, educated, industrialized, rich, and democratic. And much of the data that is used to train AI models is from these societies where WEIRD might be applicable, right? Information scraped from Reddit, information scraped from Wikipedia, etc. This means that the worldview embedded in the data and then the annotated data and therefore the model will reflect a narrow cultural lens. So you might wonder how this actually happens, given that a lot of the data labeling, as we've talked about, happens in the global south, right? So there's a few important reasons. First, as we just chatted on, a lot of this raw scrape data that is training platforms like ChatGPT or Midjourney is coming from places like Reddit, Wikipedia, Stack Exchange. These are dominating training corpora, right? Second, we also see global cultural diffusion of Western values, right? Where Western values are held up as the default perspective, even outside of the West. So this means that annotators might unconsciously reinforce norms that we would consider weird. Third, the annotation guidelines and instructions phases are often created by Western companies or institutions, and this includes, just even a regular assumption about what counts as respectful, toxic, funny, or correct. These are not universal understandings across the globe, and so this has an effect. And lastly, I would say is these annotators are typically annotating in English, but they're from across the globe, right? So there's a language bias there, and it also actually signals to another idea, which is that there are several languages that are quite underrepresented in the training of large language models, right? So these models actually function much better in Spanish, English, or Chinese, but there's a few other languages where you might not be getting the best output. Lisha is a great example, as someone coming from languages, Lisha is a great example of one that does put out good information in various languages. And then lastly, many of these annotators are working under pressure. So they're guided by quality checks and review processes that prioritize speed and the quantity of tags that you're able to get through in a day rather than quality. So, if I'm sitting down and I'm gonna make $10 in an hour, and it's not really, if I'm gonna make $10 in an hour, but that's based on the amount of tags that I get done, I'm gonna just be clicking through, right? And we do see that in some of the data we get. We'll take a look at that. So when we look beyond where the model is trained, we have to ask whose worldview is being used to decide what's true or fair or appropriate. So let's just take a look here. This image highlights a form of representation bias that emerges in AI-generated visuals of different occupations. So we see average faces generated for about 7 different jobs, I believe. And this was a Bloomberg article that actually utilized stable image diffusion to create 300 images per profession, right? And we see that the high-paying occupations like architect, lawyer, and CEO tend to be associated with lighter skin and male features, right? For low-paying jobs, janitor, dishwasher, housekeeper, often more associated with darker skin tones and more feminine features. We can measure this on the Fitzpatrick skin scale on here on the bottom, which is a dermatological tool used to measure skin tone. So this is not necessarily the result of an explicit individual bias. It's more likely the result of biased data patterns in the training set. So AI models learn from large-scale internet data where stereotypes around race, gender, and socioeconomic status are already embedded. We can see this, even further. When we look at the gender breakdown of the data set we just looked at, right? Here we see that there's a stark breakdown by gender. 2 out of 300 images for engineer actually demonstrated female traits. And then we would see that actually 0 out of 300 images for housekeeper demonstrated masculine traits. So, what does this mean in real life? This is a very prescriptive way of looking at who can work what job. So when you all are applying to your jobs and you're putting your resume is going through an ATS and you're like, why am I not getting seen, right? This type of data plays in there because if a model is trained on data like this, it might assume that certain people are not fit for certain professions, right? So let's just, we're kind of getting to the end here, so I'll kind of just jump into a few real life examples from Sapien. A few months ago, we decided to put up a breakfast image upload project. We wanted to collect some sample data from our taggers across the globe, and we put up a croissant, some scrambled eggs, bacon, pretty harmless, right? Well, what I would say is that we started to get interesting data back in the sense that it was useless. So we would get AI-generated images, we would get stock images, we would get stocking images again. We would get memes. We get a lot of memes, just so many of these. And a lot of this data was completely unusable. So we really had to take it back to the drawing board and look at, who are our taggers? What does breakfast look like for them? This might seem like a small item, but it really does affect the way our taggers are able to participate in our system. So we put up a few images that are reflective of our tagger base, and we started to actually get some effective data from this. So we collected metadata, we saw real image breakfast uploads, and we are able to actually utilize this now for off-the-shelf sale. So, I could dig into that more, but we'll just kind of wrap up here. There's a few ways that we can actually address bias and data annotation. We can definitely work on diverse data sourcing where the sampling pool is larger and pulled from across the globe. We can source decentralized taggers. This is an initiative that Sapien is really working on. Our decentralized workforce really ensures that we're getting people from across the globe. We have 120 different countries, I believe. Let's see. So we do have a tagger distribution across the globe. With also different language distributions. This really affects the quality of data that we're getting. And then we also can account for ambiguity and confidence. So we can allow for confidence scores for annotators to rank their confidence on a specific tag, right? This is how we do it at Sapien. We provide a sliding scale for how confident you might feel in a specific annotation. And then lastly, robust training programs. This one's pretty simple, but if you have continued training programs on how bias trickles down, this will always stay present in the annotator's mind. So just to kind of wrap up here, to move forward, we have to reframe annotation as skilled interpretation, right? It's not just mechanical compute. A lot of these companies just consider the people who are training data to be part of a stack. These are actual humans who have different ways of viewing the world and different understandings of what a population looks like. So we need to design pipelines that acknowledge this uncertainty, this subjectivity, and the place that our annotators are coming from. We also need to rethink quality to include diversity of thought, not just accuracy. Quality would signify actually representing a larger portion of the population rather than just a few. And lastly, invest not only in better data, but in better conditions for the people who created it, right? So garbage in, garbage out, it goes the same for bias. Bias in, if you put it in the data, you will be getting biased answers out. We've seen that throughout this talk. And if AI models are built from our collective human labor, then AI's future is really not about replacing people, it's about reflecting them appropriately. And so we don't just need more data. We've tried that with Midjourney. We need wiser data that will then produce wiser systems. So thank you. I hope you've really gathered something from this talk.
Yeah. Hi. Hi.
Hi.
Yeah. So you just started with the tokenization, right?
Mm-hmm.
So recently I heard the news about Google something with the dolphin data kind of thing. So they're working on dolphin sounds.
Mm-hmm.
So how they tokenize the sounds and like they collect all the data, right?
Yeah.
But how they tokenize that part and how they understand that thing.
The question is for me.
Yeah. Like
about how.
Do you have any idea like how they tokenize the sounds?
I would say probably an AI engineer is a better person to answer that, as I focus on text-based and image-based. But I do think that's a really curious item to inspect. I'm imagining it's like large swaths of data that they're collecting and then pairing with different interactions or actions based on animal behavior. But I would definitely say check that out further.
Thank you. Thank you.
Yeah.
Hit me.
Okay,
Go for
cool.
it.
I'm not sure if this is doing anything. On the Barbie example, like coming back
Yeah.
full circle, like what role, like solving for the South Sudan Barbie problem, what role does data annotation like just play in that? Because one thing I'm thinking of is when I think about the training data I have on South Sudan, yeah, it's full of like violence and that slice of what South
Yeah.
Sudan is. And if I'm going to make a Barbie for South Sudan, I have to choose to sort of disregard
Yes.
that because it doesn't reflect my intent. So it's more like inference time. So I'm curious, it feels like there's two pieces, what data you choose to use at the time. But yeah, I guess the question is,
Yeah.
what are some ideas for like that problem, how you might use data annotation to make a better South Sudan Barbie?
I think that there's a few things you could do here. One would be the majority of the news we're seeing in the West on South Sudan is like, you might see a lot of violent imagery, but I'm imagining that on the ground, the people that you're talking to there, that's not their full understanding of their culture. So I would first suggest like a larger sampling of the data. Also considering that most media outlets are Western skewed. And then I would also recommend potentially employing people in South Sudan to do annotation so that they have actually, we have actually an understanding of the culture. And yeah, you wanna go ahead? Yeah.
Into your society's relationship with various concepts.
Right.
And I guess like any sort of work that you do with the technology, it's really just like you're just trying to correct for
Yeah.
okay, this is how my society has chosen quite realistically
Yeah.
to see Sudan. And now I have to like compensate for that because it's goes against like, my profit margin,
Right.
whatever is important to you.
I think you make a really fair point, which is unfortunately kind of what Chris was talking about in the prior talk, that people are looking at the ethics of data as a historical problem, but it's a systemic problem. So yeah, it is definitely like addressing both items. I think that just looking at, there's a few items that go into this, not only the data, but also the way we prompt the model. That's really important as well, and that accounts for human subjectivity. So I definitely agree that there is a certain systemic issue here. That is kind of like the root of what we're trying to get at.
Thank you so much.